This video is a continuation of the examples of regression equation. So the example, given data x1 bar is equal to 6, x2 bar is equal to 7, x3 bar is equal to 8, sigma 1 is equal to 1, sigma 2 is equal to 2, and sigma 3 is equal to 3. R12 is equal to 0.6, R13 is equal to 0.7, R23 is equal to 0.8. Find the regression equation of x3 on x1 and x2. Estimate the value of x3 when x1 is equal to 4 and x2 is equal to 5. The solution: we shall solve this problem. According to the method, the regression equation of x3 on x1 and x2 is x3 minus x3 bar is equal to sigma 3 by sigma 2 multiplied by R23 minus R12 into R13 divided by 1 minus R square 12 into x2 minus x1 bar plus sigma 3 by sigma 1 R13 minus R23 into R12 divided by 1 minus R12 square into x1 minus x1 bar. So substituting the values, we get x3 minus 8 is equal to 3 by 2 multiplied by 0.8 minus 0.6 into 0.7 divided by 1 minus 0.6 whole square into x2 minus 7 plus 3 by 1 into 0.7 minus 0.8 into 0.6 divided by 1 minus 0.6 whole square into x1 minus 6. This implies x3 minus 8 is equal to 1.5, 0.8 minus 0.42 divided by 0.64 into x2 minus 7 plus 3, 0.7 minus 0.48 divided by 0.64 into x1 minus 6. This implies x3 minus 8 is equal to 0.89 x2 minus 7 plus 1.03 x1 minus 6. This implies x3 minus 8 is equal to 0.89 x2 minus 6.23 plus 1.03 x1 minus 6.18. This implies x3 is equal to 0.89 x2 plus 1.03 x1 minus 6.23 minus 6.18 plus 8. This implies x3 is equal to 0.89 x2 plus 1.03x1 minus 4.41, which is the required regression equation of x3 on x1 and x2. Now, estimation of x3. Putting x1 equal to 4 and x2 is equal to 5, we get x3 is equal to 0.89 into 5 plus 1.03 into 4 minus 4.41, which is equal to 4.45 plus 4.08 minus 4.41, which is equal to 4.12. Hence, x3 is equal to 4.12 when x1 is equal to 4 and x2 is equal to 5. This is our required estimation of x3. Hence, this brings us to the end of regression and correlation. So, a short note or a recapitulation of the formulas. Regression equation of x1 on x2 and x3 is x1 minus x1 bar is equal to s1 by s2 into r12 minus r13 into r23 divided by 1 minus r23 square into x2 minus x2 bar plus s1 divided by s3 into r13 minus r12 into r23 divided by 1 minus r23 square into x3 minus x3 bar. Regression equation of x2 on x1 and x3 is x2 minus x2 bar is equal to s2 divided by s3 into r23 minus r12 into r13 divided by 1 minus r square 13 into x3 minus x3 bar plus s2 divided by s1 into r12 minus r23 into r31 divided by 1 minus r13 square into x1 minus x1 bar. Regression equation of x3 on x1 and x2. x3 minus x3 bar is equal to s3 by s2 into r23 minus r13 into r12 divided by 1 minus r12 square into x2 minus x2 bar plus s3 by s1 r13 minus r23 r12 divided by 1 minus r square 12 into x1 minus x1 bar. And the standard error of estimate is 1.23 is equal to root under summation x1 minus y1 whole square divided by n minus 3, or as 1.23 is equal to root under 1 minus r square 12 minus r square 13 minus r square 23 plus 2 r 12 r 13 r 23 divided by 1 minus r squared to 3. Hence, this brings us to the end of correlation and regression.